so the integral from 2 to 5 of x minus 3 squared over x dx. So I'm going to start by integrating, by squaring x minus 3. Then I'm going to divide the x into each term of the numerator. Then I'm going to integrate term by term. So the antiderivative of x is 1/2 x squared. The antiderivative of -6 is -6x. And the antiderivative of 9 over x is 9 ln x. And I'm going to integrate from 2 to 5. So first I plug in 5. So 5 squared over 2 is 12.5. 6 times 5 is 30, plus 9 ln 5, minus, plug in a 2. 2 squared is 4, times 1/2 is 2, minus 12, plus 9 ln 2. Make sure I don't make a mistake. -17.5. And then I have minus 2 plus 12 is 10. And then I have plus 9 ln 5 minus 9 ln 2. I will check it on my graphing calculator. So math 9, integrating from 2 to 5, x minus 3 squared divided by x dx. So this is going to give me a decimal approximation. So I'm going to type in my exact answer and see if it is the same thing. 10 plus 9 ln 5 minus 9 ln 2. That is not the same answer. Oh dear. What did I do? $12.5 minus 30 minus 2 plus 12 is -7.5, not 10. All right, let's see if that fixes it. -7.5 plus 9 ln 5 minus 9 ln 2. Was that the answer? I think that was it. Yeah, that's it. Okay, I'm going to evaluate these two integrals. One of them has bounds, part B, and the other one does not. So the integral without bounds means find an antiderivative. So a function whose derivative is 3x squared would be x cubed plus c. So it's a whole family of functions, all of whom have a derivative of 3x squared. Now part B is a definite integral. It has bounds, so it does involve taking an antiderivative, x cubed, but then we have to evaluate that antiderivative from 1 to 2. So first I plug in a 2, 2 cubed is 8. Then I plug in a 1, 1 cubed is 1, and I get 7. So these questions look similar, but their answers are drastically different. Over here, for the indefinite integral, my answer is a family of functions. And the answer for my definite integral is a number, representing the area under the curve 3x squared between x equals 1 and x equals 2. Okay, without using a calculator, decide which of the following definite integrals are bigger. So I can't use a calculator, but I can use my knowledge of graphs. So x squared looks like that from 0 to 1, and x cubed looks like that. Right? So it's a little bit flatter between 0 and 1. So I think there's going to be less area here than here, and I drew that really exaggerated. But I think that the x squared is going to be bigger. So if I do a quick evaluation of each of these integrals, the antiderivative of x squared is 1/3 x cubed. If I evaluate that from 0 to 1, I get 1/3. And the integral from 0 to 1 of x cubed dx, the antiderivative is 1/4 x to the 4th, evaluated from 0 to 1 is 1/4. So it is correct that the integral from 0 to 1 of x squared dx is bigger.